enjoyed working alongside the GIZ and the Indonesian Biogas Association to put this market report together. And I hope that you enjoy hearing about it. So first up, we have our CEO at the WBA, Charlotte Morton, with some opening remarks.
Well, thanks, Jo, and good morning to everybody. Many thanks for joining us today, wherever you are in the world, for the launch of the WBA and GIZ India Market Report. As Jo said, my name is Charlotte Morton, and I'm the Chief Executive of the World Biogas Association. Now, let me first tell you briefly about the World Biogas Association. It's the global trade association for the biogas, landfill gas, and anaerobic digestion, or AD sectors. We were founded now just a little over 6 years ago by national associations from the United Kingdom, the USA, and Italy, along with 20 founding company members. But today we represent well over 100 organizations from all around the world, including about 30 national associations from every continent. The WBA is an official observer with the UNFCCC, a partner of the Climate and Clean Air Coalition, the CCAC, a member of the CTCN and Global Methane Initiative, and a partner of the C40 Cities Network. We also now sit in the leadership groups of the CCAC's Waste and Agriculture Hubs, which is particularly significant as the CCAC is the secretariat for delivery of the Global Methane Pledge. We also actively engage with many other organizations, such as the Food and Agriculture Organization, the European Commission, UNEP, the International Energy Agency, and IRENA, partly to ensure recognition of the industry's enormous potential, but I'm pleased to say now increasingly to coordinate our activities towards facilitating the rapid scale-up of the industry. But exactly why is this industry so important? And why is it so important that it scales up as fast as possible? Well, we humans, directly or indirectly, generate over 105 billion tons of organic wastes globally every year, all of which release harmful methane. Methane has a warming potential 86 times higher than carbon dioxide when averaged out over 26 years. And that, together with other greenhouse gas emissions, are being emitted from those organic wastes directly into the atmosphere as they decompose. Indeed, 21% of anthropogenic methane is derived from manures and slurries, municipal solid waste, and wastewater. However, if instead these wastes are captured and recycled into biogas, biofertilizers, bio-CO2, and other bioresources, this industry could deliver 50% of the global methane pledge, as well as to produce enough green gas to replace 1/3 of today's global natural gas consumption, which is, of course, also critical for the global gas crisis. To achieve all of this, we obviously need every biogas market around the world to develop and mature as fast as possible. And it's for this reason and part of our work that we publish country market reports, which outline the potential for the market, the biogas sector in specific countries. The reports look at the current market, the full potential for market development, opportunities for growth, and potential barriers. And for this report, the GIZ worked alongside us and the Indonesian Biogas Association to publish the report on Indonesia. So I'd particularly like to take this opportunity to thank both the GIZ and the Indonesian Biogas Association. The report provides an insight into the sector in Indonesia and will be an invaluable introduction to any company looking to invest in the Indonesian market. With policy moving in a promising direction and vast amounts of feedstock from the palm oil and tapioca industries, from livestock and sewage treatment, the Indonesian market is positioned to expand rapidly. However, as with any new market, there are always challenges to overcome if the full potential is to be achieved. And it can be insightful to learn from other countries. So today we've invited Divyesh Desai from Shell to provide his insight into how production of bio-LNG was scaled up nationwide to decarbonize transport in India. He'll be providing information on the policy drivers and technological gaps that were addressed in India, and the potential for these to provide the basis for change here in Indonesia. After Divyesh, WBA's technical strategy lead, Charlotte Marcel. You can never have too many Charlottes. Charlotte will talk about the importance of minimizing risk, ensuring health and safety, and having robust regulation to improve confidence in the market for investors. So again, many thanks to all of you for joining us. And I will now hand over to Joe, and I hope that you find today's session insightful and learn all you need to do to become a part of growing the Indonesian biogas industry. Thank you.
Okay, thank you, Charlotte. Next up, we have Dodi from the GIZ, who will be presenting the findings of the report. So over to you, Dodi.
Thank you, Joe. Could you start? Yes. Yeah, first of all, I would like to thank Charlotte and all WBA team for cooperating with us in developing this report. So basically, this report will outline the current status of biogas market in Indonesia and also the opportunity that we can develop in the future. So Joe, you may proceed to the next slide. Yeah, first, I would like to introduce about GIZ first. GIZ is German Development Agency, and we are also working in Indonesia since 1975, including development of microhydro power plant back then. And right now, German-Indonesian cooperation are focusing on 3 priority areas, including energy, environmental protection, and also TVET, or economic development. And as one of the energy project in Indonesia, our project Explore is mandated to promote renewable energy, which has significant greenhouse gas mitigation potential, including agro-industrial waste utilizations for the energy. And we've been partnering with ministries, with Ministry of Energy, Ministry of Development Planning, and other ministries, and also private sectors, and also financial institutions to promote these renewable energy technologies since 2012. And now with this market report, we expect to explain the current situation in Indonesia and also invite other companies, other development partners to support this endeavor in Indonesia. Next slide, please. Yes, with regards to biogas development in Indonesia, we can categorize into 2. The first one is small-scale biogas, and this refers to household scale biogas application. Normally, the feedstock is from the cow dung, and the current capacity is around 27 million cubic meters per year, and this mainly funded by state budget. Donors, special allocation funds also from the government, and also corporate responsibility program by the private enterprises. And the main application is for the cooking for remote communities. And for your information, Indonesia is currently importing significant amount of LPG, and this has caused significant energy subsidy for the state, for the Indonesian government. So this program is also aimed to reduce this subsidy. And then the second application is industrial scale biogas. The total capacity is around 160 megawatt. And then this is mostly integrated with the agro industry, especially palm oil mill and also tapioca. And this is also mostly for electricity or power generation, including captive utilization, and also exporting to the grid using excess power, and also independent power producer. Next slide. Yes, and for the next slide, I will focus mostly on the industrial scale biogas in Indonesia, because we are focusing on this application. So in terms of feedstock, 83% the feedstock is coming from palm oil mill effluent, so or POMI. Normally, POMI is not treated, So the common application is using land application, but still, if this is untreated, it emits a lot of methane to the atmosphere and contribute to climate change. So this is also significant technology to capture the methane. And then the second feedstock is also tapioca wastewater, around 15%, but most of a big tapioca mill in Indonesia is already implementing biogas digester. And then only 1% from manure. We have a lot of cows in Indonesia, but this cows is on the household level, so it's not really big. Only several big uh, livestock company exists in Indonesia, so this is a bit difficult to combine it as industrial scale biogas application. So there is only one project that we understand available in Indonesia. And most of the applications is for the electricity production, either for captive consumption in the palm oil mill or tapioca mill, or feed the electricity to the grid using the excess power or IPP. And there are also other applications such as biogas co-firing for boiler. This is interesting because normally the agro-industrial company uses higher value biomass such as palm kernel shell, but because this is higher value, so they can save this palm kernel shell and sell it either to domestic demand or export it to other countries because it has a higher value. So this biogas co-firing can be used to replace this shell use for boiler, and yeah, in returns they will get additional revenue by selling more palm kernel shell. And then the second application that is emerging is biogas upgrading or biomethane plant. Currently, there is one, but there are also more project development on these biogas upgrading plants in Indonesia. So we expect more um, biogas upgrading plants in Indonesia in the near future, either for vehicle fuel for trucking in the palm oil plantation, or for uh, a commercial or industrial customer. So, for example, in North Sumatra, Unilever has announced to buy bio-CNG from one project developer. Could you go to the next slide? Yeah, so this is the potential of the biogas, the industrial scale biogas in Indonesia. We estimated around 1.3 gigawatt technical potential, and this mainly contributed by palm oil, around 900 palm oil mills spread across the country, but especially in Sumatra Island and also Kalimantan Island, with the potential around 1.1 gigawatt. There is also tapioca, and this is mostly located in Lampung. This is southern part of Sumatra, around 65 mills and 153 megawatt potential, and also animal farm. So in our database, we have collected around 29 farm with 36 megawatt potential. So in terms of the installed capacity is not that big, so around 12% or 162 megawatt of biogas plant in Indonesia. Next slide. Yeah, so about the drivers for the market development, I can categorize into two: the internal drivers and also external drivers. So the internal drivers is because the increasing price of fossil fuels that is normally used by the agro industries, for example, the diesel fuel for electricity or for trucking, and also the electricity itself. So by using biogas, they can save the operational costs from this increasing fossil fuel price. And then second one is the opportunity to get additional revenue by selling renewable electricity or renewable energy gases like biomethane. And as I mentioned before, through biogas co-firing, so basically the company can sell more higher value biomass either to domestic or export market. And then the external drivers is, of course, we have climate and also renewable energy target, which just amended our NDC. So it's called enhanced NDC with the increased greenhouse gas mitigation target by 2030. And the government also announced the support of Global Methane Pledge. And for your information, the Ministry of Environment and Forestry is also currently preparing this zero waste roadmap for the Indonesia that will also include um, the promotions of environmentally friendly technology to reduce the methane emission. And of course, we also have a renewable energy target. And I will explain a bit about the regulations of for selling biogas electricity to PLN. Another drivers is of course the carbon economic value. So the government has issued the president regulations on carbon economic value, but the implementation is not yet started. So meaning that there is also opportunity for tapping this carbon economic value by implementing biogas projects in the future. Um, and of course, for the country, it is important to have a better energy security by reducing energy import and also focusing energy subsidy for those who need most. And on the right-hand side, so we have these regulations for selling biogas electricity to utility. We can categorize into two. The first one is IPP or independent power producer, and then the second one is success power. So the government of Indonesia has also issued the presidential regulation on the renewable energy. With this new regulation, it has a better tariff. So it's a 20 years contract period and two-stage tariff. For the year 1 to year 10, the tariff is higher because to help the company or project developer achieve the payback period. And then for the stage 2, for year 11 to 20, the tariff is lower. And for the excess power scheme, the minimum is 3 years contract period, previously only 1 year. So meaning this is improved regulatory framework. And since most of biogas installation is using captive power, so they can export the excess power to the grid using this scheme. So this is a preferable scheme, as I say, for selling biogas electricity to the utility. And the selling price is, of course, is not is different compared to IPP because this is assumed that most of the investment already uh, allocated for the captive power scheme. And in the bottom, you see that this is the project development plan for PLN. Until 2030 is approximately 590 megawatt is planned for bioenergy power plants, including the biogas. Next slide. Um, yes, I'm not repeating the internal and external drivers. It's just explaining options for biomethane utilizations because this is also emerging applications in Indonesia. I can categorize into 4 applications. The first one is biomethane injection to gas pipe. So this is common application in Europe, US, but there hasn't been any project in Indonesia. But what I can say is that there are many interests from the gas operator in Indonesia, and they are also preparing one pilot project on this. And there is also a company who are also interested to buy either the green gas certificate or have a direct contract with the biomethane project developer. So this is mainly a RE100 company who wants to increase the energy supply from renewable energy. And then the second application is compressed biomethane. This is similar to CNG business that is also existing in Indonesia, especially in Jakarta and West Java. It's just similar. We upgrade the biogas and then we compress and transport to industrial and also commercial customers. And then the third application is truck, and this is very specific application, and because palm oil mills are normally located far from the city, so transporting diesel to this location is also costly. So that's why the project that I mentioned, one biomethane project, Indonesia is currently utilizing biomethane for fueling the truck. So the truck is used to transport the uh, palm fresh fruit bunch of palm oil. Yes, and then they are using this biomethane. And of course, the fourth application is diesel fuel substitution through DDF, dual fuel, and or also gas engine. So this is relevant because Indonesia is aiming to reduce the consumption of diesel fuel for power generation, and the biomethane could be used to just replace the fuel itself without changing all the power plants. In the bottom chart, you can see the comparison of biomethane and fossil fuel prices. So this is the range for your information. As you can see, the biomethane price range is very competitive compared to other fossil fuel competitors ranging from diesel, LPG, and CNG. But please note that this is non-subsidized fuel. As for your information, the gas price for special industries, the pipeline gas is very low, like around 6 USD per MMBTU. So biomethane cannot compete for that. But for other application, non-subsidized, biomethane is very competitive. Next slide. Yes. The barriers to market development, the first one is, of course, grid connectivity, because most of palm oil mills are located in remote locations and normally don't get access to the grid. If the location is more than 10 kilometers, not worth it to connect to the grid because the connection cost is very expensive. And then the second barriers is, of course, seasonality, and this is basically relevant for palm oil. And as I mentioned before, the energy subsidy in Indonesia is very big. So for the electricity, the coal price is capped at 70 US dollar per ton. And the natural gas for special industrial applications is capped at 6 US dollar per MMBTU. So this is also become a barrier when promoting biomethane in Indonesia. Especially there is no feed-in tariff or special tariff for biomethane yet in Indonesia. And then, of course, the financial institution is not fully aware about this technology, and most of the time they consider generally renewable energy as small projects and also high risk because they are used to finance fossil-based power plants with 100 megawatt gigawatt capacity. So this is a just different size. And then for the mill owners, so they consider the investment cost is high, and sometimes it is not their priority. They prefer to allocate their investment um, to other things to expand their business. So especially this is true before because there is no clarity in terms of the market from the government at that time. But now with the new presidential regulation, it is expected to change the game, and they are more motivated to develop biogas plant. Next slide. Yes. So we show this one case study from PT Dharma Satya Nusantara. So this is the only company who operate the biogas upgrading plant in Indonesia. We have another company, but the capacity is not that big. So we always mention that DSN is the only project who is running biomethane plant in Indonesia. So they have around 60 ton per hour palm oil mill capacity, and they the produced biogas is to run the gas engine, and some is also used to be upgraded as biomethane. As I mentioned earlier, they mainly utilize the biomethane for vehicle fuel for their trucking, and also for fueling the genset near the plantation areas, because the location is very scattered, so they have the genset for running and running the biomethane. And I believe they are also planning to build more, because the location of palm oil mills is also close to another. They have around 6 or 7 palm oil mills close to one another, and they can just utilize or develop several biomethane plant and basically utilize it to energize several palm oil mills. And I believe this is very good case study, because the potential replication in Indonesia is very big. And yeah, hopefully this could be a game changer in promoting biogas in Indonesia. So that's all my presentation. I would be happy to answer questions if any. Thank you.
Thanks, Dodi. That was really interesting, and I hope that it showed that there really is a lot of potential for biogas in Indonesia. And I just want to take this opportunity to say thanks again to the GIZ and the IBA for working alongside us in this report. It's been really interesting to learn about. So yeah, thanks again. I've seen that there's a few questions in the Q&A box. I'm going to save them till the end of the presentations, just so that we make sure that we can get through them. So I'm going to move on to our next speaker, who is Divyesh Desai from Shell. And he will be talking about the policies and technologies needed to roll out the use of bio-LNG widely in India. We hope that this offers some insight, and it may be useful in the Indonesian context, but also globally. So yeah, over to you, Divyesh.
Thank you very much, Joe. Good morning and good afternoon, ladies and gentlemen. Let me quickly introduce myself. I'm Divyesh Desai. I work for Shell. I work in a new fuel, or on the low carbon fuel business of Shell. I'll spend a minute or two on what we are trying to do, I would say, on RNG space across the world, with a more focus on India. So we are in a renewable natural gas space. We are focused in a United States and a Europe and in Asia. Obviously, the US investment has been driven more by the incentive-based regulation, which really supports more and more RNG projects to be built on the back of a RIN credit and a certain favorable regulation, which helps you to make a robust economic case. A Europe business continue to be driven under the compliance requirement of having a certain amount of blending in the business, which you have been doing in terms of retail marketing. Now, when you move from I would say it was the east side of the world and look at the ways they have been working specifically on low carbon fuels and for the purpose of this discussion, renewable natural gas, we really do not see any specific regulatory landscapes being developed by any specific country, and again, there are reasons for that, and there are very plausible and logical reasons sitting for not having those regulations. So in that context, what you see in Asia is an individual country driven approach in terms of how you really build in a good RNG or a bio CNG or a biomethane business, considering your own constraint challenges and the problems which you really want to sort out. So while in a previous discussions, I was just hearing about the drivers from Indonesia, and why Indonesia choose to do that, the amount of feedstock you have, and the policies and some sort of a competitive prices of products like CNG and LPG and others, and also some sort of subsidies been around in the region. It's the same thing if you look at the country like in India, and that's the purpose of probably my next 8 to 10 minutes on this subject, that maybe like to really talk about how we see this thing has been unfolded in India. What are the things which government has done or the private sector has done, and it is in a way reaching to a point where you do see that things are, I think, are about to take off, and that there's a significant amount of an investment has been progressing as we speak in RNG space in India, and the outlook is pretty bright. So really like to share some sort of a learning which I have experienced in specifically in India while we try to do something around India. For every country, the reasons, I would say, internal, externals, are going to be different. And for India, there were, if I really look at the key reasons, there were two. maybe 3 or 4, but couple of them are pretty prominent one. The first one is in India is in a hugely import dependent country when it comes on energy requirements. So we need as a country around 4.5 to 5 million barrel of an oil every day, and out of that almost 80 to 85% is required to be imported. So we are hugely import dependent country. That's number one. Two, you also need in a world like this where the oil prices are going to jump from 40, 50 to 100, 120, it put a significant pressure on your forex outflow in terms of the way you want to run your forex businesses, and more importantly, I would say the keeping the parity between the way the rupee or the exchange rate parity, which is important for the country to maintain. So that's one. And when I go from an energy requirement more towards, say, a gas, which probably could be the closest comparison here, as in a country, we need around 40 to 45 million ton of gas, and within that, half of that, approximately speaking, has been coming within the country. That means it's all been produced inside the country, and almost 50% of that, so close to the 20 million ton, is imported one. So that means you import LNG from the world and you pay the prices the way the world prices has been moving on. So in a relatively, I would say, the stable world, you do see the oil prices remain in the range of $60 to $80, and with an LNG price linked to 14 to 16%, you do see that the India do import on an average at, say, $8 to $10 per annum BTU, and in a bit of an abnormal market environment which we are seeing now, I mean, those prices can go, I mean, we all know the numbers, right? They just cannot be explained. It goes 20, 30, 40s and beyond explanation. So in that context, it's really important for India that how you really can do whatever you can do within the country. So that's the first point. And the second one is about the amount of I would say, the waste or the feedstock available in country. Being a highly unorganized country and in a huge in geographical sense as well, we have a huge amount of municipal solid waste been spread across the I would say country. A huge amount of I would say the agro residues, which are going to be extremely useful as we progress further, I would say, in this RNG and the biofuel journey. And this makes the whole thing little interesting for the country, that, okay, you have a good amount of feedstock available in country. You also need a huge amount of gas to be imported from the world. And the technologies required to make the whole this thing works in terms of converting feedstock into the gas are not something which is extraordinarily, I would say, been available only within a few companies. I would say they're pretty off the shelf sort of on technology been available, and you can just really start to put it into the practices. So these two reasons in a way lead to thinking within the government of coming out with some sort of a biofuel policy which has been introduced 3 years ago in the country, and that biofuel policy in a way incentivize a specific agro residue for I would say driven and MSW driven bio CNG projects. That means the renewable natural gas plant, and also to a certain extent bioethanol projects, because we still import a good amount of energy, and if you can really blend the ethanol into your gasoline, it helps you to spend more or spend less and save more, I would say. So a bio policy which government has come out with has a very few, I would say, important element to support these industries, and it in a way has set up on a few principles, I would say, which are really important for the country to progress further. And let me talk about those principles, and where something probably, I'm not sure how the Indonesia is going to probably pick up this path of commercializing the whole bio CNG. But in India, this whole commercialization of an RNG has I would say 3 or 4 pillars, I would say. One would be that since the feedstock supply is in a highly unorganized space, and it's been spread across the country, there is a good amount of an aggregation support which you need to make the feedstocks work for the businesses. And to that extent, there are many feedstock aggregators started to came into the, I would say, into the arena, and started to set up their own shop or their own businesses. And there isn't a right amount of I would say, the financial ecosystem exists in terms of PE money, and the government supposed to make those sort of feedstock businesses work, which is extremely important to have a reliable sort of supply chains to make this project work. That's number one. Then comes the very important element of the route to the market. That means assuming the technology has been available, which is not really a complex thing. What you need to do is how you really find out the home for the gas in a most profitable manner for the projects. And in that context, there are again two separate, I would say, the products which are important here from the Indian context. One is a natural gas, which is a biomethane, and second is I would say digestate. I will come to that a little later. But in case of a biogas, what government has done was really supported the a bit of prices for the biogas productions plant. So whoever has been manufacturing the biogas or on a renewable natural gas through the a biogas mechanism of those projects, a government in a way had ensured that through the national oil company and the city gas distribution company, there would be an assured price, and the assured offtake has been offered to those manufacturers. And that assured price been offered is to the extent of an 80% linkage to prevailing CNG prices. So if you really look at the pricing's been prevailing at this point in time, that goes as high as a 24 to I would say $30 per MMBTU. And when you look at an 80% of those numbers, you're in a way looking at a number closer to $20 per MMBTU. And when you look at the, I would say the cost of doing an RNG projects in a places like India, and for that matter, be it in Indonesia, Malaysia, since we are trying to do some work in Indonesia as well, I would say that it is going to be in the range of $12 to $14 per MMBTU. And that leaves in from an Indian perspective, a pretty decent margin for the manufacturer really to come and set up their own projects. So that is a clear support by the government in terms of offtake prices, which is linked to 80% linked to the CNG, which really gives a good support. That's one. The second one, which again I learned in the case of Indonesia also, is there a bit of a plan which has been going on in terms of how you can really synchronize all the biogas manufacturers within a grid. So there is I would say the policy framework under discussion at this point in time, that whoever would be manufacturing the biogas may have an opportunity or probably I would say the option to really put in his gas through the gas grid and probably selling it to the market in a way whoever can really pay the green premium of those gases. Now that mechanism is still required to be worked out, but yes, there is a clear thinking which has been progressing within the whole ecosystem to synchronize the biogas manufacturing projects or the plants within a gas grid, and that's pretty important. I would say step. So these two steps: one is giving the right price support, and second one is that working out the physical infrastructures arrangement in a way where the route to market is not been constrained because of I would say the challenges of moving the cascades and things like that, but you can just pump it into the grid and can move it wherever you want to. So these are the good policy interventions which has been really progressing and really supporting the country in a great possible way. And the second one, which is the digestate. Now, again, India become one of the agricultural based economy. We really have a huge amount of I would say the fertilizer manufacturing capacities, and also been importing good amount of fertilizer from the global market. It is really important for a country like us to really setting up some sort of a mechanism where this digestate can be brought into the systems of the way the fertilizer has been allocated by the government to the farmers, and in that sense there is a thinking or an action has been going on within the fertilizer ministry to bring this digestate under the fertilizer control orders, where there is an obligations for the fertilizer companies to offtake such a digestate, and eventually ensuring that goes up to the farmer along with a urea which has been distributed by the retail dealers, I would say. So this is also a very important thing, since this manufacturing projects in a way have a liquid, many of them have a liquid digestate and the limited storage. If you really can't find the home for that digestate, you in a way lead to again chalking your infrastructure and stopping doing what you are supposed to do, which is an RNG manufacturing. So I would say the solving that bottleneck in terms of finding out the home through the policy support is extremely important for these projects or for this industry. And India has been really doing a fairly good amount of work in terms of really supporting this infrastructure requirement. So there where we are, I would say, in India. And if I say the result over here in that sense is that I would say between 70 to 100 projects have been up and running, and there are hundreds of projects have been planned in the pipeline. There is a government been in a way coming out with capital grants and a capital subsidy for the new projects for the states. There are specific interventions been in a way also been given by the states, since India is in a state and federal I would say the driven political system. Huge amount of support has been coming up. So if all goes good, India has probably capacities to go to thousands of bio CNG projects, which match within the government plans of going up to 5,000 projects in the next 5 to 7 years. Yeah, so there where we are, I would say, in terms of our development within country. Yeah, and I like to focus, as I said, thanks a lot to say that having a little clarity around that this presentation or discussion is more around India. Our plans for Indonesia and Malaysia have been shaping up, and we will have more to talk about it later. But I really like to have all these discussions around India at this point in time. Thank you very much.
Thanks, Divyesh. That was really interesting. I think what you were saying a lot about the regulation and the need to have guarantees on what's going to happen to the digest date and the prices is really important and resonates quite a lot. So yeah, thank you for sharing that with us. So finally, we have Charlotte Marcel from the WBA, and she's going to be talking about the importance of risk management for improving investor confidence. So yeah, over to you, Charlotte.
Thank you, Joe. And good morning and good afternoon to everyone. So yeah, I will. Oh yeah, you can go to the next slide, Joe. Yeah, in the report that we produced in the about Indonesia, we spoke about risk. That yeah, sometimes you need some confidence to invest in an AD plant because of the risk. So I was just wondering, or I thought it was important just to remind what can be risk in the AD sector. So you will have some financial risk when you invest in an AD plant, because you have to find, for example, the good way of procuring your AD plants and yeah, everything around. Then when you operate, you can have some bad performances. The plant is not operating as you wanted it to be. You also can damage the environment because of yeah, everything you produce in your plant. And also you will have some risk relating to health and safety. So the risk for the workers at your plant, the risk for the plant owners, because if you happen to have someone who die in the plant, then the plant owner might go to jail or to have very high penalties. And you can also damage or have impact on the people around, which are not who are not on the plant. So yes, when you invest in an AD plant, you have to think about risk. And I think that everything around risk can just go to cost. So risk is cost in any sense that you can think of it. We can go to the next slide, Joe, please. And so what we wanted to highlight at WBA is that if you develop an AD plant, you have to think about the best practices before you start your AD project, because you don't want to have bad case studies, you don't want to have bad plans because of your money and because all of the policy, the government around you and investors wants to see good plans. So then you will have the good conditions to produce more and more biogas and to have more and more biogas plants. So what is managing health and safety in an AD plant? It's thinking mainly of all the orange words we have on the slides. So for example, ATEX, you can have some explosion from your biogas or from dust you have on the plant. So yes, you have to think about everything. You can have consultants, many knowledgeable people to support you with not omitting any risk or anything you would have in your AD plant, to be sure that you will protect the health and safety of workers, any people around, and also the safe operation of the plant itself. And then it will support you with having a good ROI, return of investment. We can go to the next one, please. What is managing environmental performance? You have to think about all the emissions you will have on your plant. So it can be water emissions, air emission, noise can be a pollution too. And with the air emissions, you have all the greenhouse gases emissions. So managing it is, once again, thinking about that, list all the risk you could have, all the amounts, you have to do calculations too. And sometimes, depending on the countries, you have some regulations, environmental regulations. So you have to know them and you have to design your plant to be able to comply them. Also around managing environmental performances, you can do some life cycle analysis to just determine the sustainability side of your biogas you're producing, your biomethane. And this could have high value when you want to seek for gas certificates and relating to CO2 emissions. So this is another point important when you develop an AD plant or you operate an AD plant. We can go to the next one. You have also to think about operational performance, so which could be the plant efficiency. How long will your plant be running the whole year? So how do you enhance it to the highest level? It can be around the quantity, quality of your products, how rich in biomethane your biogas is. How is your bio CO2? Is it, does it have a high rate? How polluted or how good is your biofertilizer? So if you want to earn money and if you want your plant to be good, then you have to think about that from the beginning. And also you want to enhance the maintenance costs and times. So you have to think about your maintenance plan and equipments. We can go to the next one. So all of that, we at WBA, we would like to develop an international certification scheme, which could be called the International Anaerobic Digestion Certification Scheme, or ADCS International, which would cover the all the phases, so from the development, the design of the project until the operation and maintenance, to support the AD developers and AD operators with good practices, best practices, and to be able to not omit the important things. So this would be a scheme with audits and guidance, written guidances, to be able to develop your plant the best way, to have the best references to support the policies around biogas and AD, and improving your return of investment in the plant. So this is one of our projects, and another one around that is to support regulations, framework for regulations and policies for the countries who need that to speed up the development of the biogas. So these are some of the big projects at WBA. We are still in the very early process of them. So, but we will work on them during the new year. And so if you are interested in joining, if you have feedback, if you want to, you have resources for that. So please contact us and we'll work together on that. Thank you very much.
Okay, thanks, Charlotte. That was really interesting. I think a lot of important lessons for everyone in the biogas industry across the world. So exciting times at WBA as well. So we have some time for some Q&A now. We have about 10 minutes. I can see that Rizki has been busy answering some of the questions in the chat box. So if anybody else would like to submit some questions now, now is your time. We have one open question on, we still have CO2 that release open air during purification process. Can you advise how to utilize this for better environment and also economical? Charlotte, do you have any ideas on this, or anybody else on the panel at all?
One of the maybe most common way of using the CO2 from the biomethane or biogas processes is to capture it. So usually when you separate or when you upgrade your biogas into biomethane, it's easy to capture the bio CO2. And then you can use it in many ways. So it could be used for industry, different industries such as cryogenic cleaning, or many different industries. And it can also be, if it's high quality enough, you can have a food grade quality and use it for the food and drink industry. So yeah, there are two major ways of using the CO2, and there are some technologies existing around that.
Yeah, thanks, Charlotte. So the next question is, will the report and/or slides be shared with us? Thanks in advance. So the report will be accessible through the WBA website, and we will share the slides with permission from all of the speakers if they want to. So we can send that in a follow-up email after the session's finished. So we have another question. There's been a lot of talk about making regulation more consistent or streamlined to enable the industry to expand as quickly as it needs to achieve net zero. Do the panel agree with this? Any opinions from the panel?
Well, I can certainly say that from our perspective, I think it's going to be vital. And it's one of the WBA's projects to look at how we can develop a standardized set of regulations that can be made available to countries to use as precedents, ideally keeping as close to them as possible. I know that talking to some of our developer members, if you have to employ teams of people to understand the regulations in every country, it takes a huge amount of time and effort just to learn what those regulations are, to adapt your technology necessary to meet them, and that just creates delay. And the global methane pledge target is 2030, which is just 7 years away. So if you think about how long it takes to build one plant, and the fact that we need to build tens of thousands of plants if we're to capture all the methane emitting organic wastes that we are generating, then we really need to do this as fast as possible. And so standardizing the regulations, standardizing the standards and certification schemes will enable industry to scale up fast, but also safely. And that's our focus is very much looking at developing those kind of standardized regulations and certification schemes that will support industry to do that.
Does anybody else from the panel have an opinion on streamlining regulation and policy?
Yeah, let me add to that. I fully agree with Charlotte. And in addition to the case of Indonesia, though, in terms of the economic point of view, this is already feasible to develop 80 projects in Indonesia, but things not really moving forward. I think that the government need also to intervene by providing incentives, by providing a realistic and also yet ambitious target. And of course, regarding the global methane pledge, I think this is global initiative that most of the countries are agreeing, and there should be some kind of peer learning among different countries on how to best implement this initiative in each country, because individual countries they have their unique characteristic. They have different agricultural, they have different energy situation that needs to be addressed specifically. So, but the target itself is globally relevant, and I think we could exchange among the policymakers to how to best organize this global methane pledge within their respective country. Thank you.
Thanks, Dodi. We have another question. So how many biogas upgrading plants will be constructed in the near future? And do we have any information regarding those plants? I presume that means in Indonesia. So yeah, any remarks on that?
So yes, some companies have announced that the number, but I cannot recall how many, because they are just different initiatives by different companies. Some are project developers, some are also a consortium between project developers, agro-industrial company, energy company and also the gas operator company. And this is also linked with the VCM, voluntary carbon mechanism. So there is already they already recognize the value of carbon in this project. And there is also initiative by, of course, DSN. They will build more biomethane plant in Indonesia. So yeah, I cannot tell the number, but there are a number of project development, definitely.
Thanks, Dodi. Do we have any final questions? Just put them in the chat box if you do have some. Okay, if we don't have, oh, one in the chat. Thanks for the presentations, everyone. Okay, so if that's all for now, then if you have any further questions, then please feel free to email myself or the speakers, and I can disseminate getting those questions asked for you. So thank you all for joining us and all of the speakers and panelists that we have here today. The report will be on the WBA website, well, it is now, and we'll be sure to send the link through to everybody who's been at the launch. Thank you again and have a good rest of the day wherever you are. Thanks again to the speakers. I've really enjoyed this. So yeah, thank you all.
Thank you, Joe.
Thank you very much.
Thank you, Joe.
Thanks, Dodi.
Thank you. Thank you,
you.
Charlotte.
Thanks to
Bye.
all.
Bye.